And now let's move on to the inverses of the trigonometric functions. And I want to start with the inverse of sine of x. And I just let you know that this is not equivalent to sine of x to the negative 1 power. So this notation may be a little confusing, and some may prefer this function to write it like this instead, as arcsin of x, because it leaves less room for confusion. But I prefer writing it like this because it saves room when I'm writing. Okay, anyway, so if we have the way to prove the derivative of the inverse of sine of x is by implicit differentiation. I'll have to set y is equal to the inverse sine of x, and then we'll have that sine of y is equivalent to sine of the inverse of sine of x, and then we'll get that sine of y is equal to x, because as such it's just the nature of inverse functions. Like if you have f of the inverse of f of x, then you'll always get back your x. Okay, so now let's take the derivative of both sides, and you'll have d dx of sine of x is equal to the derivative of x. Now you'll have to apply the chain rule. First, the derivative of the outside is cosine of y, and then multiply it by the derivative of the inside, which is dy dx is equivalent to 1. Now we have that dy over dx is equivalent to 1 over cosine of y, if we just divide both sides by cosine of y. But there is another way we can write cosine of y, because we know sine squared of y plus cosine, that's a plus cosine squared of y is equal to 1. Then and cosine squared of y is equal to 1 minus sine squared of y, and we take the square root of both sides, and we'll see that cos of y is equal to the square root of 1 minus sine of y. So 1 over cosine of y is equivalent to 1 divided by the square root of 1 minus sine. Oh wait, I forgot the square here, sorry. 1 minus sine square of y, and that is equivalent to 1 over the square root of 1 minus sine of the inverse of sine of x, and all squared. And as we've already established, this will always spit x back out if we have a function of its inverse function. So this is equivalent to 1 divided by 1 minus, uh, wait, sorry, 1 divided by the square root of 1 minus x squared. Okay, some of you may be wondering, when you take a square root, you usually end up with a plus minus. So why did I only worry about the plus side of this square root? Well, I had to cut. Okay, so cosine of y should be equal to the plus minus the square root of 1 minus sine squared of x. But remember, y is equal to sine to the negative 1 power of x, but the inverse of a trigonometric function will always just be equal to some angle. And for all the angles which the inverse of sine is defined lies between, well, its maximum is at 1, sine's maximum is at 1, and its minimum is at negative 1, and the corresponding angles are pi halves and negative pi halves. So these are all the angles for the inverse sine of x. They're in the right half of the trigonometric of the unit circle. But remember that cosine of x is only negative on the left side of the unit circle. And since the inverse of sine of x can only correspond to some angle in here, it's only defined for angles in which cosine of x has to be, in which cosine of y has to be positive. So all of this must be positive as well.